Assalamualaikum warahmatullahi wabarakatuh. I'm Mr. Aminur from YMS EduTech Learning Hub. In this video, I will revise with you the topic of moments. Now, this topic of moments is a topic that was covered when we are in Sec 3, and it will be one of those topics tested at the O levels. Let's take a look at what you will be tested in this particular topic. The first one will be applying the relationship that moment of a force is equal to force multiplied by the perpendicular distance from the pivot. Now, writing this in its formula form, you get m equals to force multiplied by distance. Number 2, applying the principle of moments. Principle of moment states that when an object is in equilibrium, the sum of the anti-clockwise moment about a turning point must be equal to the sum of the clockwise moment. Meaning to say, when the object is in equilibrium, it doesn't move, it doesn't rotate. Now let's take a look at the first type of question that you will see during the examination. The first type is the calculation question that involves the concept moment is equals to the force multiplied by the perpendicular distance of the force from the pivot. Let's take a look at the question. The figure below shows a system for raising a heavy piece of metal of 12 meters at position W into a vertical position X. A man pulls on a rope with a horizontal force T. The piece of metal has a weight of 2000 Newton and is freely pivoted at A. The system is in equilibrium. Part A, calculate the moment produced by the metal's weight about the pivot A. Now let's calculate the moment produced by the metal's weight about the pivot A. Moment is given by force multiplied by distance. So this force here, they are referring to the weight. The weight. So it is 2000 Newton multiplied by the distance must be a perpendicular distance. So which of these values of distances, we have 8 meters, we have 12 meters, you have 2 meters, which one of these would we use to multiply into this question? The easiest way to find this distance will be by looking at the force. Now the force is vertical, right? For the weight points downwards, so it is in a vertical direction. Therefore, the distance that you take being perpendicular must be the horizontal distance to the pivot. So which distance here is the horizontal distance to the pivot? It will be 2 meters. So the answer here would be 4000 Newton meters. So it's a very straightforward question using the formula calculating moments produced by the metal's weight. Now, the next question is an explanation type of question. No calculation involved, but you need to show the understanding of the moment is the product of force and the perpendicular distance about a point. Let's take a look at part B. As the piece of metal moves from position W to X, explain how the moment produced by T changes if the magnitude of T remains the same. Look at the diagram. When the point W moves to the point X, so focus on the formula whereby M equals to force multiplied by distance. The force, in this case, the tension, is constant, but now the distance increases. Initially, it was 8 meters, and the point W moves to point X, which is higher. Explain how the moment produced by T changes. So, will it increase or decrease? Simply say, the moment increases. Explanation, because the perpendicular distance between the line of action of T and the pivot increases. Now, the previous two questions test us on applying that moment is the product of force and perpendicular distance of the force to the pivot. Now let's take a look at how we will apply the principle of moments. Let's take a look at this question. Figure 3.1 below shows part of a boiler in a steam engine. Steam escapes through the valve when the pressure inside the boiler becomes too high. When the pressure inside the boiler reaches 4.0 times 10 to the power of 5 Pascal, the valve opens. The area of the valve in contact with the steam is 2.0 times 10 to the power of negative 4 meters squared. Given the width of the uniform handle is 12.5 Newton and is 1 meter long, calculate the maximum value of M such that the valve will open when the pressure inside the boiler is 4.0 times 10 power 5 Pascal. We will write down the information that we have so far from the previous page. The weight of the handle, 12.5 Newton. The length of the rod is 1 meters. The cross-sectional area is 2.0 times 10 to the power of negative 4. And there is pressure in the boiler of 4.0 times 10 to the power of 5 Pascal. We will use all this information to help us solve this problem. By principle of moment, when an object is in equilibrium, the sum of anti-clockwise moment about a turning point must be equal to the sum of clockwise moments. Let's find the forces that are acting on this handle. First, we have the mass that will exert a force downwards that we do not know the weight of. And we have 12.5 Newton force. There will be an upward force exerted on the valve. Now, two of these forces will be causing an anti-clockwise moment. Which ones will cause an anti-clockwise moment? It will be the weight due to the mass. This is anti-clockwise moment. 12.5 Newton, the weight of the handle, anti-clockwise moment. The upward force exerted on the valve will cause a clockwise moment. Therefore, by principle of moment, we state that for the system to be in equilibrium, the sum of anti-clockwise moment must be equal to the sum of clockwise moment. Let's add the anti-clockwise moments together. The mass exert a weight of m times 10, where 10 is gravitational field strength, multiplied by the distance. The distance from the pivot is 0.8 meters. Yeah. Plus moment due to the weight of the handle, 12.5. And because this is a uniform handle, the weight exerts at the center of the handle. Therefore, the distance to the pivot is 0.5 meters. The sum of this anti-clockwise moment must be equal to the sum of clockwise moment, and we only have one clockwise moment that is due to the force exerted on the valve. How do we calculate the force exerted on this valve? There's pressure in the boiler, there's cross-sectional area of the valve, the product of these two, because force is equals to pressure multiplied by cross-sectional area. So we will take the pressure 4.0 times 10 to the power of 5 multiplied by the area times 10 to the power of negative 4. That will be the pressure multiplied by the area, giving you the force, multiplied by the distance from the pivot, 0.3. So we can simplify this expression. On the left side of the equation, we have 8m plus 6.25 equals to 24. Therefore, m equals to 24 minus 6.25 divided by 8, 22.21875, corrected to 3SF kilogram. And so there you have it, the type of question that will be tested on this topic of moments. So running through very quickly from the start, these will be the two things that will be tested in the examination. First, the formula moments equals to force multiplied by perpendicular distance from the pivot. And number two, applying the principle of moments. That says when an object is in equilibrium, the sum of anti-clockwise moment about a turning point must be equal to the sum of clockwise moment about the same pivot. So I hope you have enjoyed this video and clarify some of your doubts of this topic. Inshallah, I'll see you again in the next video. Take care. Bye-bye.